Hello and welcome to another one of these ADD videos. Today we're going to be looking at L'Hopital's rule and indeterminate forms, more advanced examples. Again, you want to be looking for one of these indeterminate forms, and only these two appear. Can you do L'Hopital's rule with infinity or 0 over 0? Ooh, I just noticed that I left one indeterminate form out of 1 to infinity. I apologize about that. But either way, all these other ones besides those two, you're going to need to rewrite into one of these two forms, the infinity over 0. So we're going to do the derivative of the top over the derivative of the bottom. But if you remember my warning to you, anytime you have a square root of a variable and the power of x is greater than 1, that usually is going to end up giving you a never-ending L'Hopital's rule. If you plug in, you're going to get infinity over infinity. Let me do a different color here. And that is definitely an indeterminate form. So let's start. Let's pretend we didn't know that L'Hopital's wouldn't work. And if you took the derivative of the top and the bottom, don't forget to write your limit on every step. You would get the derivative of the top is 2, and this can be rewritten as x squared plus 1 to the 1/2. And you would bring that down as 1/2 x squared plus 1 to the negative 1/2 times the derivative of the inside, which is 2x. And you can hopefully see the problem already. See this negative exponent right here? This negative exponent is about to bring that whole function up to the top, leaving this x behind. And when you do that, what happens is you end up with a problem that looks like this. Let's see. The 2 and this 2 cancel. So we're left with 2 times x squared plus 1 to the 1/2 over x. And then if you were to do it again, the chain rule up here, because when you plug in, oops, we forgot to reevaluate, that's why. And that gives you infinity over infinity. And if you get indeterminate, the derivative of the top oops, you see it happen again. Derivative of the bottom is 1. Again, we got a negative exponent that would bring that down to the bottom, leaving something up top. So you would see that this is never ending. It would go on for all the time that you had and patience that you had. And hopefully, sooner or later, you would realize that you're going down the wrong road. So then you got to do algebra. So when you do algebra, what you want to do is you want to factor out the common power. So when we factor out the x squared, you're going to be left with 1 plus 1 over x squared. And we pull it out of the square root. And since we're approaching positive infinity, we don't need to worry about absolute value of x. It's just going to be x. And then 1 plus 1 over x squared. X's cancel. Then anything with an x in the denominator goes to 0. So I'm left with 2 over square root of 1, which is 2. Okay, so L'Hopital's rule will not always work. All right, now let's look at this one here. Here we have, if I plug in, 1 over infinity is 0, and 1 plus 0 is 1 raised to the infinity. That's definitely an indeterminate form. So if we have one of those, what you want to do is you want to set y equal to that expression. And then we're going to use something that's used frequently in math to get exponents off their high and mighty perch that they're always above everybody else. Natural logs allow us to bring this power down as a coefficient. Don't forget that you did a natural log to both sides, because that'll have to come in later. So when you do this, you get x to the ln of 1 plus, change colors, oh well. And then when you plug in, you have to reevaluate the limit. Let me erase that. I'm going to write the ln of y equals the limit as x approaches infinity. Here you're going to get another indeterminate form. When you plug in here, you get infinity, and then we already said that that was natural log of 1 plus 0, so that would be times 0. And we want to rewrite that in a form of infinity over 0 over 0. So quick side note, if you remember when you're dealing with fractions, when you divide by a fraction, you multiply by its reciprocal, right? Well, who's to say that we can't just take that multiplied whole number and turn it back into a fraction and divide it? So what I mean by that is this x, the coefficient, can come back down to the denominator here. When you do so, you're going to end up with, I'll switch back to red, limit as x approaches infinity of the natural log of 1 plus 1 over x all over 1 over x, right? These are equivalent. If I were to divide by this 1 over x, how do I simplify it? I multiply by the reciprocal to get my original problem I had over here. But since that was an indeterminate form that I cannot do L'Hopital's rule on, I try to put it in a different form, and hopefully now I can do L'Hopital's rule. So let's see if that's the case. Indeed, I don't know why it's not erasing. There we are. And when I plug in here, I get 1 over infinity is 0, natural log of 1 is 0, and then on the bottom I get 0, because it's 1 over infinite. That's an indeterminate. And it's the indeterminate that allows me to do L'Hopital's rule, even though I'm out of space. So I'm going to go over here and try to finish that problem. So if I write down the IND, remember I wrote down IND and 0 over 0, so now I can indicate that I'm going to do L'Hopital's rule with the L with the circle. The derivative of the top is a natural log, which is the derivative of the argument, the box, in this case 1 plus 1 over x, over the entire box. So the derivative of 1 is 0, plus 1 over x has to be rewritten as x to the negative 1, then you can bring down the exponent and subtract 1. So that'd be a negative 1 x to the negative 2 over the entire base, over the entire box. When I say box, I mean this thing right here, the argument of the log. So then we divide by the derivative of 1 over x. This is for the bottom part of L'Hopital's rule, your g of x. And you should notice that that's the same thing as what I did earlier, so that's what you get there. So when you divide by this, that's the same as multiplying by the reciprocal. And then you should be able to see that these indeed cancel out. And the two negatives make it a positive. So we're left with just one plus x. And when I plug in infinity there, I get what? Just 1 over 1, which is equal to 1. Are we done? No, because we have ln of y equals 1. How do we get rid of an ln term? Hopefully you remember your algebra or pre-cal. You e both sides. And then you find out that what we just found out was the definition of e. Okay? This original problem is the definition of e. So, recapping, we got 1 over infinity, which is an indeterminate form. So what we did was we ln both sides, allowed us to bring that down as a coefficient. Then when we plugged in, we got another indeterminate form. So that indeterminate form forces us to rewrite it in this form because we can't do L'Hopital's rule with this one. It has to be either this or infinity over infinity. So what we did was we took the x and flipped it down to the denominator as a 1 over x. And you always want to pick the simpler expression. And then that allowed us to do L'Hopital's rule because it was 0 over 0. Derive the bottom, and then derive this, simplified to get this. And then when we plugged in infinity, we got 1 over infinity, which is 0. 1 over 1 is 1. So we had natural log of y equals 1. How did we get rid of that? We e'd both sides. So the answer of that e and ln cancel, and y is equal to e to the 1. All right. That is not a negative sign for those of you that think that's a negative sign right there. It's just an equal sign. All right, so I hope I've clarified things and removed any doubts that you might have. You can see that they can get rather fun, if you will. But if you practice these, they don't become too rough, okay? So thank you, and I hope I helped. Have a nice day.